Okay, so today we talk about the angle measures of triangles, and our goal is to find the angle measures in triangles. So a theorem is a statement that has to be proven. We talked about one theorem in our lesson today. A corollary follows a theorem in that it's a statement that can be proven easily using a theorem. So the corollary is going to follow that theorem. If you want to think about it, a corollary is probably going to be more specific than the theorem. Okay? Interior angles, interior just means that they're on the inside of the triangle. So it says when the three sides of a triangle are extended, the three inside angles are called the interior angles. So if I look at a triangle, my interior angles would be here, here, and here. Now what they're saying is I can extend a side out on each side, and what that does is it creates an angle here, and an angle here, and an angle right here. Okay, so these are going to be called my exterior angles. It says when the sides of a triangle are extended, the angles adjacent to the interior angles are called the exterior angles. Really what you think about is if you extend the side out, you create this angle that's on the outside of the triangle. Okay, the Triangle Sum Theorem, first theorem, says that the sum of any triangle, the measures of the angles have to equal to 180 degrees. So it doesn't matter what type of triangle it is, it's always equal to 180. If I look at this first example problem, they give me two angle measures. The measure of angle A is 35. The measure of angle B is 85. They want us to find the measure of angle C. So what I'm going to do here is I'm going to take 85 and I'm going to add it to 35, and I'm going to end up with 120 degrees here. So these two angles total to 120. And I know any triangle has to have a sum of 180. So I'm going to take 180, subtract the angles that we already have, and what we're left with is 60 degrees. So I know the measure of angle C has to equal 60 degrees. That's what's left over. Okay, so the same idea for the next one. If you want to try it, it would be 25 plus 95 would give me 120. And then if I take 180 and I subtract 120, I'm left with 60. So I get the measure of angle C is 60 degrees. Now, the missing angle won't always be 60 degrees, just that the two first example problems, it is 60. Okay? And then we talk about the corollary to the Triangle Sum Theorem. And the corollary says the two acute angles of a right triangle are complementary. Now, complementary means that these two angles have to total to 90 degrees. So in this diagram, since angle C is 90, they're saying if I were to take angle A and add it to angle B, these two would have to total to 90 degrees. That's because my triangle totals to 180. If I subtract 90, I'm left with 90 degrees. So subtracting that right angle leaves me with 90 degrees, and that's going to be split between these two angles. Okay? Now, I can use that idea with the corollary down here. I could just say 90 minus 63 because we already have 90 here. And when I take 180 and I subtract 90, I'm left with 90 degrees. So that would go here. And then if I subtract 63 from it, I am then left with 27 degrees. Okay? My other option is to add the two angles like we did before, and I get 153 degrees. And then if I want to say 180 minus the 153, I'm left with 27 degrees. And that's my missing angle. I prefer this one right here, using the 180, because then it's the same process every time. Okay? So on my next problem, I'm going to say 90 plus 52 is equal to 142 degrees. Then if I take 180 and I subtract the 142, I'm left with 38 degrees. Okay? Down here, they don't give me two numerical values, they give me two variables to work with. Okay? It's the same process though. I know all three angles have to total to 180 degrees. So I'm going to say 2x plus this angle here with the square is a 90 equal to 180. If I combine the like terms, I get 3x plus 90 equal to 180. From there I can subtract 90 from both sides, and now I'm left with 3x equal to 90. And when I divide by 3, I find that x is equal to 30. And that's all they're asking for is the value of x. Okay? The next one says triangle ABC, So ABC and triangle BDC are right triangles. They have right angles in there. Suppose that the measure of angle ABD is 35. So angle ABD right here is 35 degrees. Find the measure of angle DAB. They want us to find this angle here. Okay, now if I just work with this smaller triangle, what I have is this top angle is 35. Since I have a 90-degree angle here, I have to have a 90-degree angle here. And now I have two angles of my triangle to find that missing angle. I take 90 and I add 35 to it, and I end up with 125. 180 for the full triangle. Subtract the 125, the two angles that we know, we're going to be left with 55 degrees. So this angle here that we're looking for is a 55-degree angle. Okay? On the next page, we're going to skip the top exterior angle theorem. We're going to cover that tomorrow, so that's going to be in day 2. Okay, we're going to move on to number 8, 9, and 10. So they're kind of reviewing that triangle sum theorem. So on this problem here, if I take 65 and add 50, I end up with 115 degrees. And then I'm going to say 180 minus 115, and I'm going to be left with 65 degrees for this missing angle right here. Okay, on the next one, add these two angles. So I take 45 and add it to 65, and I get 110. And if I take 180 and subtract 110, I'm left with something's not right here. Oh, sorry guys. This was a 60, so this is 105. So if I take 180 and I subtract 105, I actually end up with 75. Sorry about that. Okay, on the next one, they asked me to find the measure of angle C. So they want to know what's this angle right here. Okay, I have overlapping triangles. So I have a small triangle right here, and then I have a big triangle. I'm going to start by finding this angle right here. What is it? I take 90 plus the 50, and that's going to give me 140 degrees. If I take 180 and I subtract 140, I'm left with 40 degrees. Now that's going to be angle A right here. If I look at the larger triangle, which contains angle C, I know angle A is 40. I know this angle B is 90, so how could I find angle C? I'm going to say 90 plus 40 equals 130, and from there, if I take 180 and I subtract 130, I end up with 50 degrees. Something unique about this problem, these two angles right here. So if these lines are both forming two angles that are the same, these are considered your corresponding angles that we talked about in the last chapter. And if the corresponding angles are congruent, then the lines are parallel. Once I know these lines are parallel, this is another pair of corresponding angles. So they have to be congruent to each other. Okay, kind of a special case. We're going to skip down to the last two problems on the page. So number 17, okay, our triangle has to equal to 180. I have three angles here. I'm going to add them together. So 7x plus 3 plus 3x minus 3 plus that last angle, that square, means 90. All together have to total to 180. So if I combine like terms, I have 7x and 3x. That gives me 10x. I have 3 minus 3 would give me 0 plus 90 equal to 180. From here, I'm going to subtract 90, and I'm left with 10x equal to 90. And then from there, if I divide by 10, I find my x value to be 9. And that's all they're asking me to find. In the next one, same idea. Find the value of x. So I add all three angles together. I say 8x plus 5 plus 4x plus 6 plus 5x minus 1 equal to 180. Okay, combining the x's, 8 plus 4 gives me 12. 12 plus 5, 8 plus 4 gives me 12. 12 plus 5 gives me 17x. I have 5 plus 6, which gives me 11, minus 1 gives me plus 10 here, equal to 180. If I subtract the 10, I get 17x equal to 170, dividing by 17, and my x value will be 10. So that's all for today. We had a textbook assignment in class today. The assignment was textbook page 182, I believe. 182. We did 5 through 11, 18, 20, 24, and 25. And that's our assignment for today. Happy day!